First of all, thank you everybody for taking the time to listen to my speech today. I am currently doing my PhD on cycling safety, coming from it with a geospatial perspective. So just to give a background, it is being funded by the Road Safety Authority of Ireland, and some of the surveying companies here in Dublin have provided me with data, one from Murphy surveys, which have given me mobile laser scanning data. And then the second survey company did a drone survey of my study area here in Dublin. So the background motivation, cycling safety, there's huge promotion throughout the world to promote active travel, to meet the sustainability development goals for health, for many reasons. One of the underlying issues of cycling is safety and concerns about safety, and figures provided would show that there's far more cyclist fatalities and serious injuries occurring than, and these numbers haven't decreased over the last 10 years since various initiatives have been implemented. This has resulted in a Vision Zero strategy, which aims to reduce the number of serious injuries and fatalities by 50% by 2030 and by zero by 2050. And in order to achieve these targets, data-driven, evidence-based interventions are required. Part of this ties into the study I'm undertaking, and I've looked at the factors that are contributing to cycling safety and how, as geospatial technologists, we can actually identify and help to understand these. And these are divided down into surface quality, which leads to cyclist collisions, street objects where they can cause cyclists to collide with them, or for visibility, the gradient, and also visibility. These are all factors that contribute to cyclist collisions. In addition, the targeted road safety inspection as part of the Road Infrastructure Safety Management Directive, which has been amended in 2019 to include vulnerable road users, has a list of geometric objects that they recommend are surveyed in great detail, and they recommend using these high-end spatial solutions. So to move on, I used cyclist collision data provided by the Road Safety Authority to identify a number of hotspot locations in Dublin City. And one of these was Portobello Bridge, which I'm focusing my talk to you today. The question I had is, which Lidar data capture method provides the best solution? We've got terrestrial laser scanning, mobile laser scanning, and drones. So what the study did was it undertook a survey using each of these methods and then compared them to find out which was providing the best solution. The workflow, the normal workflow, point cloud registration, cleaning of the data, removing noise from it, segmentation into different categories or classifications, and then using this to create a three-dimensional model and also a surface. So I'm just going to start off looking at the digital elevation model, which was part of the analysis, was required for the analysis. So the terrestrial laser scanner, even though it provides a much more dense point cloud, it doesn't provide full coverage. So it's not ideal for this type of survey for the digital elevation model. I'm showing also the point cloud of the ground surface from the drone and the mobile laser scanning. The drone survey was done very quickly and provided a really good coverage for the entire area. Then for the actual evaluation of the quality of the road surface, the mobile laser scanning provided a much more uniform coverage of the ground. The drone was it didn't provide enough detail to create a good elevation model for the actual curbs and so on. However, when a ortho photo was superimposed on it, it provided a very good method for looking at the actual quality of the road surface at the edge, in particular where the cyclist lanes would be. The terrestrial scanner, which I'm showing here, does provide very good detail about the actual curbs and drop surfaces, which is important when considering road safety. For street furniture, including traffic lights and signposts, I've just provided an example of the type of detail that was provided from both the mobile laser scanning and the terrestrial laser scanner. The terrestrial laser scanner, far more dense, so when it came to generating a three-dimensional model, was far more easy to extract that type of information. And then finally, the generation of the three-dimensional model, which I'm just showing here in this slide, that it provides a very useful environment for undertaking analysis. So the analysis that was taken was using visibility analysis. Now I've used ArcGIS Pro to do that. And in this example here, it just shows the green lines showing where it could be visible. There's further analysis done on this to show which lines, where visibility from the perspective of a car, where they can see a cyclist traveling along a cycle route, which is part of this actual model that I've got here. In this, I've used a driver eye height of 1.05 meters. So the assessment of the Lidar data capture, the terrestrial laser scanner was good for certain types of the analysis, however, poor when it came to creating a digital elevation model and for gradients because of the way the actual point cloud radiates out and we lose coverage when we're close to the actual instrument itself. The mobile laser scanner provided very good coverage. However, from a visibility perspective, the actual level of detail captured for buildings would have been poorer quality. The drone provided very good digital elevation coverage when it came to just a general digital elevation model, which was useful. But for street objects and surface quality, it wasn't so good. Okay, so to conclude, the point cloud data does provide a good alternative for road safety assessment. And by combining these point clouds together, it's going to provide the best solution. The outcome, this is ongoing research, and what my research would show is that it's not just using this data on its own, combining it with other information. So the other information which is contained in those cyclist collision reports can provide far more in-depth and rich understanding of the contributory factors associated with these cyclist crashes. So I'm going to finish up my talk now. So thank you for listening, and please feel free to ask me any questions. Thank you.